Alrighty, time to do another one. Reschedule meetings for maximum free time. I think part one was yesterday. You're given an integer event time denoting the duration of the event. You're also given two integer arrays, start time, end time, and length n, each of length n. These represent the start and end times of n overlapping meetings that occur during the event, starting at time 0 up to time event time, where the nth meeting occurs at start time I, end time I. You can reschedule at most one meeting by moving its start time while maintaining the same duration, such that the meetings remain non-overlapping to maximize. Maintaining the same duration such that meetings remain non-overlapping to maximize the longest continuous free period of time during the event. This seems like the exact same as yesterday. So you can schedule at most one meeting, so you can only change one. The longest continuous free period during the event. Return the maximum amount of free times possible after arranging the meetings. What? Seems the same but easier. Note the meeting is going to be rescheduled to a time outside the event. And this version is valid for the relativity ordering of the meeting to change after reschedule. Oh, okay. So previously you could not change the ordering of the meetings. I see. So here you can just move this thing over here and get 0, 2 to be free, so the free time would be 2. Here it'd still be moving either this middle one to the start or this middle one to the back, and you get 1 through 8, so 7, or 2 to 9, which is 7. This one, I assume that you would want to move this thing. I think you want to move this thing here. So you get 1 through 7 as the free time. So it would be 6. 6, yeah. And then you can't move anything in this one. Okay. Okay. So which one? I guess example 3 is the one that I would want to kind of work with in terms of figuring out something that is a reasonable construction of what to do. Because I guess here there's the option of moving the first block to somewhere here. I guess what's the relevant things that could happen here? You can move the first block to maybe. It's always going to move the first block to the edges of the next blocks, right? Like to be adjacent and make a continuous kind of event chain. So you can move the 0, 1 to become 2, 3, or 4, 5, or 6, 7, or 8, 9. So how would you determine which one to move? It needs to be something where you can move it, and the size of this event is within the kind of free time available. So if this was size 2, then I can't move it to be between these two. Okay, so for example 3, it's like, say A, X, X, B, X, 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 where the X's are free, C, X, D. So the free blocks are 2, the free block sizes are 2, 3, 1. So A being, the event A being size 1, I can move it to any of these. Well, technically it'd be something like 0, 2, 3, 1, right? In theory, there could be some free time before the first block and after the last block. In this case, event time being 10, and it's first block it's starting at 0 means that there's actually nothing there. But anyways, so A being event 1 size, or time 1 size, I can move it to the end, and that would combine 0 and 2. That would make size 2 if I move this thing over here. or if A is moved to the 3, then it would combine either the 2, no, what happened then? A is moved to the 3. That wouldn't really get me anything, would it? No, it would actually. It would get me 3 here. So if this block A is moved to this 3 here, then the size of the block, which is 1, or size of this event, which is 1, is inserted into here. So this 0, 2 becomes 0 plus 1 plus 2, which is 3. If this was something bigger, let's say the first block was like 5 size, and everything was screwed down, so it's like everything moved down by another 4, then this would be 0 plus 4, plus 0 plus 5 plus 0, or 2 plus 5 plus 0. So yeah, so if this was moved here, well, then it wouldn't fit here anyways, but let's say it was somehow inserted rather than just like dropped in. Anyway, so this would form a 3 here. This would reduce this to be possibly a 2. So this thing moves here. 3 minus 1 is 2. Okay, sure. Okay. Interesting. So the size that you would get after the movement is based on the size of the block that's moved. And then, so this is maybe I guess it's like an insight or like a hypothesis or understanding. Okay, so logic, I guess I'll note size of free block after movement of event, let's say K, is going to be size of new free block. Is going to be x plus k, x plus length of k plus y, where x and y are the free slots, new continuous free slot, size of x plus size of k plus y, where x and y are the sizes of free slots before and after k. And again, only possible if k can be moved, which is there requires free slot of size k, size size of k elsewhere. So not adjacent to this, I don't think. Because if it is adjacent, then it just becomes the sum of the thing. If you are moving if you're moving event into something where it's not adjacent to it, if you're moving an event where it's not adjacent to it, then yeah, you have to move the event to something that's not adjacent to it, otherwise you're not really combining anything. Well, if this was 1 and this was 2 here, and I moved it. Yeah, I guess you are. I guess like, yeah, so or if kind of just if moving event k to kind of either side, so not to kind of just shifting it to be adjacent to its prior or succeeding event. Size of free slot after movement is sum of x plus y, where x and y are as before. Yeah, okay. So for instance, if I'm moving this thing to either this side or this side, then it's just going to be 2 plus 2, which is 1 to 3, and then 3, which is 4 to 7. So 2 plus 3, which is 5, which is basically 2 to 7 or 1 through 6. Okay, so alright, I'll try to do this in one pass. No, I actually don't think I can do it in one pass. Because I need to know, I want to calculate the largest size blocks and the largest, I want to calculate both the largest free size and largest free size blocks. So actually, can I do that one pass? Can I do that in one pass? Alright, I'll try to do it in multiple passes first, because I don't think it. Yeah. Do it in. Okay, I'm gonna do the less optimized version first, maybe. So before it's gonna be maybe a free array. So this is a size of free slots before or between events. I'll say the current time is going to be 0. Just to make this, I'll say n is equal to the length of the event time. And just to make this a little easier, kind of a small hack to make computation easier. I'm going to say event start time is going to append the event time as an extra, and the end time is going to append infinity as an extra. So in effect, having a dummy ending event with times event time to infinity. And then I'm going to say for every index in range n, I'll say this is free slots. the amount of free time is going to be the start time of this event minus the current time. And I'll append that to the array. And then I update it. Update the current time to be the end time of this event. I think this should be n plus 1. And then I'll just go ahead and print this to make sure this is correct. I feel like I'm missing something here. I think that's actually maybe correct. Length of, whoops, this should be just start time, not end time, not event time. Okay, 0110 is, I think, 0. Yeah, free slots shouldn't start with 0. Free slots should start with just nothing. One 0610 110 0610. It should be 02310 02310. Okay. Alright, so that part is done. And then I want to iterate through I guess the key thing is I'm pretty sure I can do this sorted. If I had a sorted list of available free slot times, I can do a single pass of the events and see kind of best shifts, maybe. Am I guaranteed that I can determine that? Actually, maybe I can't guarantee that if I sort, I can maybe lose some of the information. Alright, I'll do it like without worry too much about optimization. So what's the just a straightforward path of doing this? I'll say I'll have a sorted free, which is sorted of the free slots. And I'll say this is going to be reverse equals true, I think is the thing. Python sorted reverse. I think this is reverse equals true. Yep. So I want to be looking at the biggest free slots and then to the smallest. Well, the issue also is the fact that I need to know where to move it to. And it can't be something adjacent. So like I need to know that I'm moving this thing to here, and this gap is not adjacent to this thing. Yeah. I can track it by adding I can create a tuple rather than a single value for the free slots. The tuple with it's like free slot and then like the index. Free slot to start index and the end index such that no. I move it here. Move this block. Free slots are 0, 2, 3, 1. You can look at the index of the free slot. So the first event will have free slots that are adjacent to it at index 0 and 2, or 0 and 1. The next block will have index 1 and 2. So 0 goes to 0, 1, so the nth block will go with the nth free slot and nth plus 1 free slot as adjacent to it. I I'll start with the largest event time and work to these. I would check. So it's always possible to combine two adjacent event times. So I guess I could possibly do something where as I'm computing the free slots, I can compute like the simple thing, which is rearrangement based on shifting it sideways, the event without kind of changing the ordering. So let's say answer is originally 0. And I'll say, what would I say here? Let's say free block is going to be equal to would need to be working something different than this. It probably need to be start time of index. Start time is 0. Okay. So what does free block mean? Free block is the two free block. This is formed by shifting event to create one free block. I.e. that shifts event, move event without changing ordering, combining pre and post free times. So let's say the two free block is starting with start time of 0. And then I think this thing needs to be 1 to the index. And the current time is actually current time is not current time 0, it's actually current time of end time of the 0th one. So then you go actually to the second block. You calculate the free time between the first event and the second event. You add that to the toFree block. You add that to the event, to the free block array. Change the time and then answer equals maximum of the answer in this toFree block. And then you remove, as a precursor to doing the next one, you remove the prior free from this. So free of what? Free of index minus 1. If its index is 1, you add the 1. Yeah. If index is 1, then you're going to calculate this thing, 3 minus 1, which is 2. 2 plus 0 will be the toFree block time that you would get if you just shift this. And then you remove 0. So now you're back to 2 as your free block. So now the next time you do it, it's going to be 2 plus 3. You get 5. Okay. I think that's correct. The other way that you can do this is after you create the free slots. The free slots array, it's going to be like just iterate over every pair, consecutive pair, and see the sum of those pairs, and then keep track of the maximum pair that you have. But this is doing it in that single pass instead of doing it in a second pass. Okay. I'll just print out the best toFree block. So this is going to give int object is not scriptable. Whoops, this should be free slots. That's going to be the array at this index. So I printed out 1. So if I did a shift on this one, well, that should be 2 actually. Oopsie. Why would that be 1? End time of 0. Start time of 0. Start time index. This should be 1 plus 1, no? 3 minus 2. Okay. Well, I can see why this would add up to 1. This is not... Oh, I must have screwed something up. This should be 1, 1, 0. It's no longer 1, 1, 0. It's now just 1, 0. Free time, add, append, end time. I wonder why this is 1, 1, 0 now. Why it's not 1, 1, 0. Yeah, this should be like 0, 6. Oh, I see, yeah. think I forgot to add it onto the, oh yeah, I forgot to add it to the thing. So based on this change here where I start at index 1 rather than index 0, I think free slots should actually start with start time is 0. Okay. Now this goes back to 0 rather than 2. It's all zeros. Okay, yeah, my indexing is now. Yeah, this indexing is now should be just minus. No shifting by 1 since I added something at the start. This is still off. Yeah, what is going on here? So should be minus 2. Index starts with 1. I added onto it. So, index is 1. First time I do the loop, index is 1. And then I should be subtracting 3 slots at index minus 1 now. Index of 0. Next time I do the loop, it's 2. I should be subtracting 3 slots of add 1 to, no. Should I be starting with index equals 2? No. Start time 3, end time 2. 3 minus 2 is 1, so adds this 1 here. And then this 1 should subtract this 1. So that seems right. Guess I'm not sure why this is not going to 2. Okay, so it goes 1. It was supposed to be n plus 2? No, I don't think so. 1 to n plus 1. 3 slots is 1, 1. Answer is maximum answer. This should be unless this is somehow 0 initially 1. Start time should be start time here should be 3. Current time should be 2. So 3 minus 2 should be 1. 2 free block should be 2 here. Three, 2, 1. Okay. 2 free block plus equals spelling stuff. What's going on? So 1 plus 1 should be 2. The answer should be 2 here. there should be 2. Why is maximum of the answer and 2 for block giving me... Oh, I'm printing out the wrong shit. Oh, I'm so stupid. I want to know what the initial answer was. Okay. Okay. So 7. This I should probably double check here. Alright, so this is 2, which is right. 7 from the 6, 1. 5 from the 2, 3. 0 from the 0, 0s. Okay, so that's it. That's the starting answer, and the secondary answer would be if I moved it, the size of the block that I moved plus the size of the adjacent things to the block. Size of the block I moved plus the size of things adjacent to the block. So if I kept track of the largest, I kept track of the largest. I think I can maybe do it without sorting. Like if I said something like for any given index, where index is kind of event index, I kept track of the biggest gap before this index and the biggest gap after this index, then if there exists a gap that is bigger before this index, whose size is the size of this event, gap being the size of the free thing, right? The size of the free zone between 2 events. So if there exists a gap that is bigger than this event size before it, or a gap that exists that's bigger than it after it, then I can move this event to one of those gaps and create a new gap that is the size of this event plus the gaps before and after this and kind of adjacent to this event. That would mean that I didn't have to sort. Yeah, okay, so maybe I can do one kind of free after, big gap after, big gap after. Actually I'll say max gap after. And it should be just make this appropriate size. So for every event, So it should be something like 0 times the number of events. And alright, so let's look at this here. So the event that is 9, 10, I want to say the biggest gap after that should be 0. And the event that is 7, 8, the biggest event after that should be not adjacent to it. So the adjacent one to 7, 8 would be 1 and 6, 6 before and 1 after. I want to say the biggest gap after is the one that's not adjacent to it, but after it to like 0. 9, 10 being the last event should always have like no gap after that. So this should be the current gap should be the last gap. So 3 slots. And I pretty much want to, I guess it's like the current max. And then for every index in range, so I'm going to have to start with this one. So this is size 3, and I want to start with index 1, so it's like n minus 2. Is it going to be n minus 2? Yeah. Maybe it should be. Maybe I can just start with the current max is 0. So the new gap is, the next gap is going to be 3 slots of basically index plus 1. So if this is 1, index 1, index 2, index 3. Actually, it's going to be index plus 2. No, yeah, it's index plus 2. Next gap is that, and then I'll say current max equals maximum current max and that next gap. And then I want to put that into the array. So max gap after is going to equal max gap after at this index. That index is equal to current max. And this is going to go downwards. N minus 2, negative 1, negative 1. Alright, I think this is not out of bounds. Okay, so max gap after, that's right. No, oops, what am I doing? So the biggest gap after this block is going to be 1. The biggest gap after this block is 0. Obviously the last one is 0. Biggest gap after this should be 3. And after this is 3. The biggest gap after this is just the 1. 3, 1, 0, 0. Okay, I think that's correct. And then for every event, size, so I need to go through the so there's the free slots and the event sizes. Event size. I need to track that as well. Well, do I? Guess I could do that on the fly. If I could. Yeah. I'll just do that on the fly. You don't need to create an array for it. Even though I'm iterating through the indices again. So every index in range. Actually, I'll say current max gap before is currently 0. For every index in range. In range n. Event time, event length is going to be start time minus end time this index at this index, and I can move it if its length is smaller than the max gap before, or its length is bigger than the max gap before or bigger than the max gap after. So if there is a non-adjacent gap before or after this event, can reorder to create a new big gap. So if the event length is greater than or equal to the max gap before, or the event length is greater than or equal to max gap after this index, then the answer is equal to the maximum of the answer and the adjacent free slots at this index plus free slots at index plus 1 plus event length. I think that's it. Did I spell max gap after correctly here? Max gap after. Incorrect here. I think I need to print out some stuff so I can figure out what the hell's going on here. Print free slots. Print max gap after. Oh, whoops! I didn't actually update the. Yeah, I didn't update the max gap before based on this. So each time I go to an event, I determine the event length. I check if it can be moved, and then I update the max gap after, or get max gap before. So max gap before, let's go on max gap before, and the current gap in the gap slots, in the free slots of this event. This event being like, unless I'm dealing with the first event. The first event will now have, after I do this calculation, will now have the prior adjacent gap to be part of the max gap before. Still incorrect. Okay, let's go and print out stuff. Max gap before. Print the max gap after and the free slots. Print free slots. Okay, so the free slots is 2310 for example 3. 2310 with 00 at the sides. And I said max gap before was 3. No, sorry, this is free slots. Max gap after, so it's 310. Sure. So I should have been able to move the, I should have been able to create a 6, right? So I should have been able to move this thing over here and create 2 plus 2 plus 3 plus 1. 2 plus 3 plus 1. So I got 5 instead. Alright, let's go ahead and just print here. Print what is changing. Change index, and then actually say current new free slots is going to be free slots at this index plus free slots at index plus 1 plus the event length, and then print out that free slots at index. It never actually created it. Interesting. Interesting. So it never actually hit this if statement. So 1 was never greater than or equal to 1. So I'm at index 1. 1 should have been greater than or equal to 1. Index in range n. So if I had event length should be 1. Oh, shucks. Well, no, that's right. Event length should be 4 minus 3, which is 1. And then 1 is greater than or equal to 0 at that point. No, let's see. 1 is greater than or equal to something at that point. Okay. Alright. Event length. So let's say index, the event length, and the max gap before. and the max gap after at this index. What is checking? Max gap before is negative. The max gap index is 0. Event length is wow. End time minus start time. Okay, I mean that shouldn't change anything really. Oh, that just made everything worse. Okay, excellent. So event length index 0, event length is 1, max gap before is 0, max gap after is 3. Is that correct? Yeah, that's right. So that changed it. Okay, this is actually correct now. Okay, so these are now wrong. So here, somehow I got a 3. To change 0 and 3. I've gotten 3 here. I shouldn't have been able to move it there. So on the very first one, 0 is the index, 1 is the event length, max gap before is 0, max gap after is 0. So how is this going to be true? Somehow it became true here. Event length is 1, greater than or equal to 0 is false. Oh, this is so, oh my god. Oh my god. Less than or equal to. Event length is less than or equal to. Oh my lord. This is disgustingly bad. Had the wrong direction for my inequality. It's truly, what the heck? Alright. Oh gosh. Could I have done this in one pass? So I basically calculated a later. What could I have done here? I mean, I could have done a forward pass and done a forward max gap before array rather than a max gap after array, and then iterated backwards rather than forwards on this thing, so that basically I can do like 2 passes rather than 3 passes. I could do that. That would save, that'd be like a 33% reduction. Because I'm pretty sure the difference between my answer and probably some faster answer is just the number of passes I'm doing. I guess it could be, I wonder if it's, I don't know if it could be done in one pass. Could it be done in one pass? It would be beyond my current level of understanding how to set that up. So yeah, I could do a max pass. Oh wait, why am I sorting this? I need to sort this right. That actually would be extremely slow if I sorted it. I guess sorting it's going to be longer than just doing like linear passes on it. Okay. I guess sorting it doesn't take that long. But yeah, I could just do max gap before as the array and a variable for max gap after, and do the reverse here. All right, I'm going to try it. I don't think it's actually going to improve it all that much, but it'll be like one less pass. So how would I set this up? It would be something like I'll have an array for max gap before, which is going to be 0 for every event n. And then it's just going to be it's initially going to be 0 at event 0. So that's actually good. Starts with the second event here. And then for the second event, it'll be, I'll have a current max before is going to initially be set up to be 0. And then I figure out what the gap is. So this would be, it has to be non-adjacent to this event. So free is currently, I should be able to do free slots. Free slots should be fine. So the current max before should be equal to the maximum of the current max before and free slots at index -1 or index. I think it should be index -1. So if I'm index 1, the adjacent gaps are going to be at index 1 and 2 in the free slots. So the non-adjacent one would be -1. And then I append that to the array. Zero, 0, 1, 1. Now let's look at something else. 0, 0. Oh, that's a bunch of zeros. It's a lot of zeros for this number of events. Oh, am I appending like, what is going on here? Current max before. How odd. What's going on? Why is there so many zeros? Max cap before 0. Oh, I already set the size of this thing. I think maybe I can just make it be empty array or starting with 0. So size of the events is size of the event here is 4. Size of this thing should be 4 too. Okay, I think the last thing is redundant. I think the last thing is not needed. Because technically I should never is it redundant? Yeah, it's probably redundant. I don't know why that is. I know this starts right. Should always be 0 as the first non-adjacent gap. Okay, yeah, it's because I have a dummy event in here. Yeah, dummy event is causing this thing to be an exercise. So I guess that's fine. Yeah. So anyways, 0, 0, 2, 3. Is that correct? So example 3, 0. And then for this gap, the adjacent ones are these ones, but the non-adjacent one here is 0. This one is going to be 2. This one's going to be 3. Okay, that's right. So then I can say that not using the max gap after, I don't use that, and then I just do the iteration here. I use a single variable for max gap after is initially 0. We're indexing the range of n minus 1, decreasing. That length is still the same in time. Still the same as n minus start of the index. And then if the event length is less than max gap before, or event length is less than max gap after at this index, then well, this is all correct. Put that out. So I'm just copy this. Create a new free slot. Maximize the answer. Max gap after is equal to max gap after. And wait, so max gap before is equal to max, so this, whoops, max gap before this index or less than equal to max gap after. And max gap after at this index, free slots. Free slots at this index, is that right? So if I'm at event index 0, 1, 2, 3, 3 would be adjacent to 3 and 4. But now I'm moving it, right? I'm moving it. So now I'm considering myself at index 2. So 2 would be adjacent to, I think this should be index plus 1. So this calculation is for the max gap after for index 2 at that point. 0, 1, 2. And the max gap after 2 would include the gap after 3. So that's index 3 and so this is index, this gap is index 3, this gap is 4. So yeah, I think that's right. Alright, I misspelled something here. Event length. Event length is not defined. Oh yeah, misspellings for the event. All right. Oh boy. All right, whatever. I am donezo. Sometimes you beat the curve, and sometimes you're the curve. The fat part of the curve. I think I'm just going to tidy this up and just call it a day. It is kind of messy. It is what it is. All right, I'm going to do one last submission to see if it changes the score at all. Hey, random variation for the win. Okay, so that's fine with me. Free slots, size of free slots. I guess this should probably be the start. I'll just make a note here. Don't like this double line small. Actimate, hack, dummy event, add dummy event to make compute easier. Okay, I guess that should be calculated after calculating the number of events. And then the free slots can be here. And so there's initially 0. I guess I actually do change the answer here. End time, the current time is 0. The max gap before is this, the current max gap before is that. For every index, calculate the free amount, the gap, add it to the 2 block, find the maximum of the 2 block, append the free, Interesting, okay. And then find the current, reset the current time. I guess maybe I could just do something that is like free gap is start time minus end time. I wonder what the other point of having a current is. Yeah, maybe I just say start time of index minus end time of index minus 1. I think that's fine. Okay, 2 free block. It's fine. Add, append, do that. I think that's necessary. Current max before is the maximum that I've seen so far. 3 slots of index minus 1. I think that's fine. Max gap before, append the current max before. Okay. Do I use free slots later on? Yeah, I do. Max gap after. Find event time. And then if there's this gap, non-adjacent gap before this, or non-adjacent gap after this, such that I can move. Okay. If possible, to move to non-adjacent gap before or after move and see if free block created from movement is bigger. I could maybe combine this into one thing, actually. I could say that if this is true and free slots of index plus free slots of index plus 1 plus the current length is greater than the current answer. Answer equals free slots of index plus free slots index plus 1 plus this event length, rather than having to calculate the maximum. I think that's correct. If possible, before and after, and free block created from movement is bigger than current answer, then update answer to size of free block created. Alright, I don't think this is that much faster. Okay, slightly faster. Okay, I think that's it. Okay, so summary, this is going to be so the decomposition of this thing is going to be, so main parts, so first logic of this solution is based on determining the biggest block created from either one, the shifting without reorder of any block to be adjacent to its prior or succeeding event, where free block created is as size equal to gap before and gap after event. 2 is moving with reorder any block to a gap to a non-adjacent gap before or after that is at least its size, obviously, otherwise you can't really move it into that gap, where free block created has size equal to gap before plus gap after plus size of event. And this is clearly shown as in example 3, where when you move this gap, which is size 1, into not one of these two adjacent gaps, but this gap here, the size of this thing is going to be 2 plus 3 plus 1, where that's like, yeah, that's the whole thing. And I guess maybe I could have done something where I could have calculated this as the start of the event after with the end of the event before. I guess that's equivalent, right? In which case I do need to keep track of gaps, maybe? Anyways, so so doing the so I guess as much of the calculation depends on knowing the size of gaps. Create an array of gap sizes. In this case I said it was my free slots. Array where free slots of I is equal to gap between event where free slots of I is equal to gap between event the ith, so 0, oh okay, where event at I has free slots of I and free slots of I plus 1 as the gaps before and after it. And then do the calculation for best2 gap. This is part 1 above for solution for getting part 1 above. Within this loop. And this is like when you create the gap, you can't keep track of the size of the 2 block. So add the current gap to the 2 block calculation. Keep the answer of the biggest one, and then subtract the prior one before adding another one, adding the gap. And then secondarily, for the other calculation, also track the other calculation, use some method for determining the biggest non-adjacent gap before and after any event, and have a loop that finds the max of current event size plus max of before gap and max, or plus sizes of gaps before and after, as long as event size is less than or equal to max gap before, or event size less than or equal to max gap after. And this is just like, it's a bit there's different ways to just kind of skin that cat, but I create an array to do the max gap before. So as I create the array to calculate the gaps also kept track of the max gap of any max gap before any index, and then iterating backwards from the last event to the first event. I kept track of the max gap after using an individual variable and index into the array for the max gap before at this index to do that kind of check. And then if the check is true, then update the and compare and update if the answer is improved by that gap. So if the event length is bigger than the gaps before, if there's a gap before that can handle this event, or if there's an event or there's a gap after that can handle this event, and the size of this created gap is bigger than the answer, then update the answer to be the size of this event or this created gap. Yeah, time complexity, this is going to be O of n for the multiple loops that pass through the array and determine the size of gaps and size of max gap before and other calculations. There's basically constant work in each loop. Notably, this isn't O of n log n, assuming that you didn't mistype anything, assuming I didn't mistype anything, as the solution didn't require any sorting of the array. And space complexity is going to be O of n to keep track of the array, the gaps, and the biggest gap before or after this index.